After examining the interoperability issues, we identify what is needed to solve them. Many problems are technical, like system not communicated or inconsistent data formats, but others involve people, policies, and data ownership. So, the requirements are not just about technology, they also include clear rules for managing data, transparency, and ensuring that the people handling the data understand it properly. To achieve effective, secure, and meaningful interoperability in smart cities, the framework must cover technical, legal, organizational, and regulatory aspects. In this video, you can see the main requirement. First, flexible data access and integration in smart cities. There are many different systems and technology used by various organizations and stakeholders. This creates a lot of heterogeneity in data formats and interfaces. To make these systems work together, we need methods that allow flexible access and integration of data without requiring everyone to use the same technical system. Different organizations should be able to process and use data according to their own needs and capabilities. For example, in Kiel, flexible data access allows integration of diverse sources like public transport, parking, and stadium attendance data. This enables stakeholders to combine data as needed for targeted insights without depending on a single shared system. Centralized ways of sorting and processing data can sometimes go against data governance rules and make it harder for a stakeholder to take part. For example, each stakeholder can share and use fan mobility data on match days without sending all the raw data to one central server. Data interoperability in smart cities based on decentralization make collaboration easier, more secure, and more trustworthy. It also helps save hardware resources. Compliance. Data often comes with ownership, privacy, or access rights restrictions. That's why an interoperability framework needs to manage access carefully and follow legal and ethical rules. For example, in Data for All project in Kiel, mobility data from public transport or shared scooter could reveal sensitive information about people's travel patterns. The platform must make sure that it is clear who can access which data, under what conditions, and for what purpose. The next one is scalability. The framework we propose should not only work in one area like transportation. It needs to be adaptable and reusable across other fields such as health, energy, and the environment. This makes its solution more sustainable, scalable, and productive. To really solve interoperability issues, we must clearly understand what is required for effective data integration. These needs go beyond technology. They also involve organizational responsibilities, legal rules, and ethical values. Defining these requirements not only helps address today's problem, but also build the foundation for secure and reliable data sharing in the future. The fifth requirement is organizational data governance. Effective interoperability depends on coordination between different organizations. Many projects fail not because of technology, but because of missing management structure. For example, on match days in Kiel, a smooth fan mobility requires coordination between public transport, parking service, and stadium management. Our framework helps assign responsibilities, build trust among stakeholders, and make collaboration easier so that data sharing and decision making run smoothly. The sixth requirement is timeliness of data exchange. Decision making in a smart city service relies on having up-to-date and timely data. For example, in key real-time mobility data from public transport, parking, and stadium attendance allows city officials to respond quickly when there are sudden increase in fan traffic on match days. This is important for emergency situations like rerouting buses or notifying emergency teams when crowds get too large. That's why the framework should support the exchange of real-time data and time series, ensuring that the system remains responsive and dynamic. The last one is semantic alignment. Simply exchange data is not enough. The data must be understood correctly. To achieve this, organizations and stakeholders need information that explains the context, structure, and meaning of the data without requiring a single standard. For example, if two systems provide data on fan mobility in Kiel, semantic alignment ensures that when the data is merged, both systems understand it in the same way. Now you know about the dimensions, challenges, and issues in data interoperability, as well as the requirement for a good solutions. In the next video, I will explain the solutions and show which solution address which requirements.